have to give it some time, I know. Just yeah. So this is kind of what I'm starting with. I'm not sure if this is what I'm looking for. This is the one that's most likely to change. But I do really like this as a background. And so what I can do here is I can actually assign macros. So I can map this to macro 1, and I can map this to macro 2. And so I can now control this from I can control these volume levels fairly easily here from automation. So that's what I'm going to do here is this is looking to be a... Oh, come on. Come on. There we go. This is looking to be probably... Let's just start it at the 2-minute mark. Yeah, start it at the 2-minute mark, and we'll play around after that. And so this is pretty simple, you know. Let's just go ahead and throw this in like there. And so what we can do is we can pull up automation, and we can go chain volume. We can go on this first one and say I want this. I want my baseline to come in slowly to come in over these two loops. And then we're going to go to the end, and we're just going to pull it down to same volume here. This is minus 38,845. There we go. And so this is, you know, the kind of fun that we can have. Yeah. Ow. So it's not, you know, obviously it's gonna be work over time, but you know, that's how it goes. Yeah. So if I gave this one more loop and pull this out one more loop, that's a bit more fitting of what we were using. And we can come and play and listen for other things that we want. User library. User library, please. And so now the loop is a 65 measure loop. We are looping. And what we're looking for here is we're looking let's pull this up a bit for when I'm not speaking. Yeah. Let me, oh, yeah, no, I want to do this differently. I want to, and this is gonna be, this is gonna be from master. I'm okay. Cool. And now I need to figure out how do I sidechain that? I'm just gonna move this over here. Not there. I want to move it there. Okay. Put a compressor on here, I think. Yeah, I want a sidechain compressor. Yeah. I'm looking at mic in. Yeah. Okay. And So. Oops, sorry. Okay. So, does that get quieter? Does that get noticeably quieter when I speak? No, not really. Is that visibly quieter when I speak? Is that visibly quieter when I... Oh, okay, there we go. RMS, no, I want... Thank you for the, thank you for the follow. Is my stream muted? So right now I'm working on sidechain compression for my, yeah, no, I'm not quite, sitting in complete silence here. But yes, music. So I'm kind of, I want to have a higher ratio here. So when I'm speaking, I want the music to be quieter, and it gets louder when I'm not speaking. Yes! Yes, thank you. Thank you for the follow. Thank you for the raid. I'm guessing I might have misread that. I'm certain I misread that at this point. But yes, music. Raid of 9 humans. Yes, 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 yes. Minesweeper's always fun. Is this, So is the volume reasonable on the music? I'm not, it's kind of hard for me to tell. Unless I did something like this. Let me see. Hello? Oh, I did the wrong thing. Okay. That's... and I'm talking, and that's not quite what I want. And now I'm talking, and that's even quieter. Perfect. Perfect. Cool. That was just me setting up my, making it so that when I'm speaking, I can set my volume up higher, but you can still hear me when I'm speaking. Yeah. So I kind of like this sound. But I don't want... This isn't the sound I'm looking for. Update Windows. Oh. Meh. So, still not quite what I'm looking for there. Oof. Ooh, that's not... That's... Let me get to a better part of the song. Like... Let me cut the loop to just this section. That's not quite right. Let me... That's not bad. Let's go ahead and... Nope, that was wrong. That was the wrong note. Okay, I like that. I like that. I like that. Yeah, that's the hope. Is for it to have good vibes. I want to start figuring out some drums here. From down here, please. You. 105% on an intermediate isn't that bad. Yep, just to prove a point. There's 3, which means there's three there, which here solves, so that means there's 1 in those 2. There's nothing there. There's 1 there, which means has to be 1 there, which clears those out. There's 2 in those 2, which clears that out. There's 1 there, which means there's 1 there. 1, 2, 3. That was maybe a waste. Yeah. Like I said, 105% on intermediate's not that hard. You are... Let's mark you as not supposed to loop. Oh, that's why. That's... Perfect. So now I need to play around with drums here. Actually, I want to start it here. The problem with me doing drums, and really doing drums, is that I am a drummer myself. Hey! The drums were bad there, yes. Yes, the drums were indeed bad. Why was I drumming without my click? Why? Why? I'm working on the album. Yeah, I'm doing pretty good. I have played rhythm games. It's kind of hard to say which ones I've played because I've played a lot of them. I don't like that. I have not. Let's quantize just a bit. So one of the problems with drum lines is you kind of just need to... Unless you do very long loops, you can't really do loops, or else it sounds horrible. And so that's why I just straight up recorded the entire thing here, rather than trying to build up loops. Because while I do have looping patterns in here, it's too annoying. Things don't repeat enough for loops to make sense. Whoa, something was wrong there. Well, I guess I'm starting back at the beginning. Oof. Late. You're late. Darn it. Ah, that's one of the problems there. I actually want a kick there, right there. That's much nicer. I want a kick there too. I hope this isn't too annoying. This is one of the reasons I don't like tracking drums. Ugh. Well, I'm glad you're enjoying it already. Stop. That was bad. That was terrible. I don't think I have heard it. Stop. Okay, let's listen to that section now. Oh, actually, I think I have heard it. Now that I think about it. See, this is why we listen to the whole section over again. Was ist sein Lieblingsfach? I think. Yeah, I've heard it. big. This one needs to be full. Whoops. Something was wrong there. Something was wrong there. I shouldn't have gone back this far, but we're gonna do it anyway. Anyway, I say. There we go. That should be better. What? Ha, I found you. That one still doesn't feel quite right. There we go. That feels right. That was a problem. There we go. Okay, so we're gonna now listen to a loop whole way through. You know, that's not bad. That's not bad at all. Except I kind of want this to be even more gated. Yeah. Yeah. Ba-ba-ba-da-da-da. Okay. Let's No. So this is definitely Nah, I'm not happy with that. Nah, don't have anything there. I am thinking this might just be close enough to what I'm looking for. To just call this demo done. Yeah. Like, so the problems with the demo left in at this point are that, one, we are, for one, it's too obvious where the looping it happens. So this'll probably be somewhere around 150% to between 1.5 times to double the length that it currently is. Just because that kind of has to be how it goes. Just so you know. But like that's kind of the plan here. Kind of the plan is to make very I guess long in a way, but the goal is to make it so that you don't notice the looping, and you definitely can notice the looping in this song. You don't know exactly when it loops there, but you can tell when it's getting into the loopings and into the section where it is restarting. And so part of making a song great for background music is to make it not feel like it has a beginning and end. And so if you can't tell where it's looping, you are better off than if you can tell. So that's just one of the things that I'm pushing through here. So, but that's not what I'm getting done right now. And I think for now this demo is solid. So let's do something wild and crazy for a change. Yeah, that, and I probably have pretty high standards for what I'm looking for in my demos. But yeah, we're gonna do something wild and crazy here, guys. Let me do... Where am I? Where am I? I'm hiding. I'm hiding somewhere. Yeah. I'm hiding, like, there. I have to get stuff set up. Let's do the one I haven't played before. I don't know if this... Yeah, it does. Okay. So, let me... just a second. We're loading. We're loading. Gotta get the right thing showing. Just a second. Okay, that's not gonna work. Give me just a sec. Not that. This. There we go. Yeah. Okay. There we go. No, it doesn't like that. Just do that. Okay. This. Let's go ahead and let this run. Not this one. Let's let this run. And this this is a game called Comet 64. And it is a coding game. So, read the values from input and write them to output after a discount of 20%. Yeah. What does this give me? Oh, see? I see the problem here. Did you see the problem there? And now... Alright, no, it's, yeah, no, I'm... Nope. Is that... Oh, so you don't like that. Okay. Oh, no, I got it. Never mind. Hi, Quellis. I see you decide to show up when I start coding. Or, that's the wrong direction. Oh. Okay. Learning the game. Oh, yes. You will learn here very quickly how much... Oh. 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 I see. Okay. Int equals reg. Reg equals int. Int minus reg. Ah. Yatta. Okay. Cool. Okay, let's get rid of those comments. So use 2 or fewer lines. Can I coalesce this? Reg equals int equals input. Cannot do that. Fine, let's open the user manual. Syntax. So I can't write to bool. it's kind of learning a language just to play a game, yeah. It's more so learning the limitations just to play a game. Okay. So switch is how I have more space. Labels and jumps, of course. Checks. For sure. Okay, that's good. So oh, I'm sure. Sorry about that. So to clean this up, I need the goals. So the goals are to do this in 2 lines with 30 steps. So okay, well, for one, I can optimize this away. Wait, no, I can't. Right, I can't. Okay. Cool, so that cleans up. Actually, no, that doesn't clean up. No, yeah, no, you are completely right. I am, and I see another optimization I can do here. So for 10 input, I got an output of 2. Oh, you know, you're right. I'm very smart here. Stop backseat gaming. The puzzle is what's fun here. Okay. So this, yeah, you can solve it too. not even gonna... No. Not even gonna give you that. So the... Syntax, logic. Oh. Huh. So I have to do that, and then jump if false. No op. Kind of. But the reason it's not is because it this is probably jump 2. Okay, what's... And labels, okay. And there. Excuse me? Oh, out. Sorry. Okay. So, negative numbers only. Okay. See? And that's one of the places where I'm like, reg equals input times -1. I'm writing safe code, or I'm writing code that handles solutions that aren't that they don't care about. You need the weight followed by the mass. Weight divided by height squared. Why would knowing multiple coding languages screw you over? In this case. So I want int equals input. Reg equals input. So the way that I learned how to code, you over-engineer to start with always. And then and then you simplify once you have a working solution. And look, my properly engineered solution has the minimum, or has the needed level of optimization. Loop. Yeah, no, that's the thing where I disagree with Scrum highly. My job is to write code that is solid and will not like Scrum doesn't agree with solid principles. And solid meaning solid, not just solid. So reg plus plus output equals reg, check reg is less than 101. Wait, check reg is less than 100. Jump if true. Inclusive means that it prints 1 and 100. So if it was 1 to 100 inclusive, it wants 1, 2, 3, 4, 5, ... 100, or 99, 100. It wants all of the numbers. Jump if true. Jump if true. Loop. Oh, duh. Yeah, I disagree with, like, Scrum is okay. What Scrum leaves, there are things that Scrum, yeah. So how do I do this better? Let's see what, so we want 2 lines. Oh, register starts at 0, doesn't it? Yeah, register starts at 0. And then can I do this? I don't know if I can do this. Yeah, I didn't think so. How? So I do have stir length, which is good. That's much. It's always nice to have stir length. This game does have IRL time. It is very useful for full screen. So I'm incrementing register. I have to do that. Somehow I can do this with 2 lines. I'm sorry, what? 2 lines. 200 or fewer steps. So I have just nulls for input. So I can't do any input tricks. Register starts at 0. I need to increment it and output the incremented number. So the fun part here is I don't even see what lines I could optimize away. You can make a beat out of that. So I'm in the So I can't. So the reason I can't do BTTV is because I'm using Restream Chat, which is used because it allows me to combine YouTube and Twitch. Let me see if I can change that, but in general, No. 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 No is my final answer. Well, I think I'm just going to leave this. Yeah, there is still Twitch exclusive emotes out there. What I can say... Oh, they're... What? Oh. Well, that's fine. Oh, look. Yeah, well, YouTube is gonna be the place that gets my real emotes once I unlock memberships, if that ever happens. Because even though I've been offered affiliateship on Twitch, I'm never gonna accept it. So y'all are never gonna get custom emotes from my channel. Never. Unless, you know, I get up to like I don't know, like partner. If I get offered partner on Twitch, that might be worth it enough for me to switch to being Twitch exclusive. But until then, nuh-uh. So is there something that I can do with output? That's... But you can't do that. You can't do that. So output is a port. Output is write only. Okay. Well, this one feels like it should be easier to simplify, but I still don't see any steps that can be skipped here. So let's look at the next place. Okay, have fun. Bye, Koalas. Wait, what? Some point there, I'm getting off somehow. So I have 43 and 4. 44 is not greater than 3. Output equals 4. Negative 17, negative 42, negative 17. Negative 9, negative 26, negative 9, 24, negative 32, 24. Oh, see, that's where I got wrong. Boom. It's just jump to. Okay. There we go. Let's just try something. Okay. Didn't think so. There is no prequel to... There is never going to be a prequel to Trace. Okay, so... That loot... So... That check does lose the value. So I have to store it. I have to. So somehow I need to shave 2 lines. music generally doesn't have sequels. Music generally doesn't have prequels. Music theory. Music is not, like, music does not generally come in series. Output only the duplicates. Okay. Okay. So the reason that you can't make your own variables is because these aren't variables, these are registers. Okay, so the algorithm here is we need to step forward by 1. So we have reg equals input. And we have our start. Start. So our first step, we want to grab the first 2 items. So int equals input. We then want to check int equals reg. Jump if false, or jump if. Okay, well, bye. Jump if true to output. Output equals. Hopefully, reg equals input, jump to start. So if it's not true, jump to start. So if it's not true, Then we want reg to equal input. Right? No, we want reg to equal int. There is a jump if false. Oh. Okay, that makes sense. I see what's going on there. Okay. So I just need to always set that to int at this point. There we go. Okay, this is easy-ish. So here we go. We have int start int equals input. I want this to go like this. Int equals int plus input. Reg equals int. Check reg equals int. Jump if false. Start output equals int. Jump to start. Int equals 0. Wow. my algorithm is optimized. It's not the most optimized algorithm. There's another pile up down there that's even smaller. But that is an that algorithm is optimized. It's not optimal, but it's optimized. Oh boy. A rounding algorithm. A rounding algorithm. Okay. So let's just do reg equal start. Reg equals input times 10. Probably not. Because if there was, then this would be a trivial question. But this is not a trivial question, so... Well, I would say this is likely not intended to be considered a trivial question. So... The first thing we're going to do is we're going to multiply it by 10. Int equals reg divided by 10. Oh, what am I doing? What am I doing? Reg equals input. Int equals reg. If check reg is greater than Oh, no, that doesn't work. My register is a float. How do I do switches? What's switch? So we can't directly read to or write from switch. So that's not going to solve what I'm looking for. Reg equals input. That's step one. Because I need my register, which is my float. To do that. Int equals reg. So that's gonna cut off the floating point. Reg equals reg minus int. Check if check reg greater than 0.5. Jump if true. Up. So this is going to be the down case. Output equals int. Jump to start. int plus plus output equals int up jump to start. Am I always rounding up? What's wrong there? Just the 9? Let's say that this probably needs to be greater than 0.4. Yeah. Round them to the nearest 10. I don't think there's a greater or equal then. I thought so. There is not. I can tell you that much. That is too complex for this game. Stream's going fine. So let me show you. We have if checks, and the only values that we show, the only options we show is greater and less than. And we come over here to this and we only show greater than and less than. So go over to disk 2. Yeah, same thing. It is a cool looking game. Okay, so I want start input wait a second. I figured out some of my problems. Can't do it on that one. Can do it on this one. Can save a line. Aha! Can save a line. Look, I can save a line. And also, I can save a line here. I can save a lot of lines right there. So close. Which means false. False. Down. Oh, right. It would help if I actually updated. So close. So close. Okay. There we go. Let's just I realized something and I fixed it up. So int equals input. I can't do a one-liner on this. Or I can't do a two-liner on this. Okay, so this is mod. So I'm implementing mod. So I need int equals input. And this here is loop, and I need this one. I need this one. And so what I'm going to do is I'm going to be int equals int minus 4. Or, sorry. Check int is greater than 4. Jump if true. Output int equals int minus 4. Jump to loop output equals int. Sorry, what? I'm smart. Greater than 5. Sorry, what? There we go. Sorry, I'm just... Okay, so my logic is bad here. Reg equals input. Divided by 4. Int equals reg. No, because there's no variables. These aren't variables, these are registers. Reg equals reg minus int reg equals reg time equals reg times 4 output equals reg. There we go. Check reg equals 3. Jump if false. Start. I'm sorry, what? Whoops. No, this is not simulated C programming. Okay, fine. Reg equals input. Reg divided by 4. Int equals reg. Switch int. Switch int. No, this isn't simulating anything in particular. This is just this is what it is. I don't feel like making that better. They won't make you do that. That's just the way that these games work. Int equals input, reg equals input. The absolute difference between the two. The absolute difference between the two. Absolute difference. Yes, it is just logic puzzles. Okay. So, to calculate absolute difference, I believe that the answer is it's int equals int minus reg. Ah. Int equals int minus reg. What happens if I do that the other direction? Okay, that makes sense. That makes sense. That makes sense. Okay. So, check int is greater than 0. Jump if true. Output. Int equals int times -1. Output equals int. Oh, yeah. No, you're right. You're right. Check if int is greater than 5, return bool, or output bool. Check int. What did I even write? Output equals bool. There we go. Okay. Int reg equals There we go. Aha! I did it in the best way. Int equals input, reg equals input. Oh. Stir equals input. Check. Stir equals input. Aha! Let's just try this. Don't. Oof. Well, have fun. I think I'm going to try to finish off disc 2 real quick here. There's only 5 puzzles left. And then I think I'll call it a night after that. So, I want okay. Yeah, good night. Stir equals input. Check. Stir equals heads. Jump if true. Heads. Start. Int equal int plus plus. Reg plus plus. Heads. Jump to start. Check input equals null. Jump if true. End. And check int is greater than reg. Jump if true. Jump if false. No. Output equals tails. Check int equals reg. Jump to end. Jump to done. Check int equals reg. Jump if false. And this here is just going to be not tails. Not tails. not draw. Yes, it is definitely a form of machine code. Well, for one, let me... This is very exciting, isn't it? Oh, see how... Huh. Oh, okay. So, what we're going to do here is we're going to reg equals input, int equals input. Check reg is greater than int. Jump if false. Boop. Boop. So if reg is not greater than int, then reg equals int. And so after this, we then do int equals input. Check reg is greater than int. Jump if false. Boop 2. Reg equals int. Boop 2. Output equals reg. Hi, Quellis. I did a dumb. I just did a dumb. These want to be want to be true. There we go. Okay. Yeah, I think we can all relate to doing a DOM. So this code is checking for the biggest number out of 3 inputs. I need to switch it to instead check for the middlest number out of 3 inputs. So I actually need to store all 3. So I think I want, can I do reg equals input, int equals input, switch int equals input. So I can't read to or write. I can't do a direct read or direct write to the switch, which that's here. So now I want to check reg. Right. So that's what I'm is greater than int jump if true, boop, boop. And now, this actually, so you can't, so you, whoa. So, yeah. Let's do this. So, how do I, so I change this. So that this int equals input ends up moving. So what if instead of doing the switch int right here, what if we did that and we did that? And we did that too. No. So I suppose what I want to do here is I want to store off one of them. It doesn't matter which one. But this doesn't work. So that's wrong. So right now we are looking to see, can I coalesce? And I think the answer is no, I can't do any operator coalescing. I can't do any operation coalescing here. So I need reg equals int. I need switch reg equals int. Jump to next. And then here I'm going reg equals input. And here I'm going to do switch int equals input. So here we are caching the big one off. Next. Okay. So now, since we've cached the big one, if the small one switch int. I want the small one to be in int. We've cached the big one. I want small to be in int. And then if reg is bigger than int, then we want to switch int and do another comparison. Let's do this better. So we have int equals input, reg equals input. Check, reg is greater than int. Okay, we're cool. We're good. So now, at this point, bool is going to be set to whether, well, jump if true. So this one. Compare. One compare. One done. Jump to one done. So if reg is bigger than int, then if reg is bigger than int, which is here, so where it's like if reg is greater than int, then if int is greater than reg. Okay. So we want goals. Reg should always be greater than int. So that is our goal. So if int is greater than reg, then we want to switch reg equals int equals input. Okay, and then we jump to one done. If reg is greater than int, we're going to switch int equals input. Okay. So that is section 1. And then we're just going to do the same thing here. And this here is going to be two compare and 2 done. But here we don't care about this as much. So we don't have anything more to input. So we're looking here. Reg is greater than int, and or reg is greater than switch input or int unknown. So then here we go. If reg is greater than int, we go to 2 compare, in which so this is the case where reg is greater than switch and reg is greater than int. This here reg is greater than switch and reg is less than int. Reg is output. It is output. Output equals reg. Cool. So here we go. So in this place, reg is greater than switch and reg is greater than int. We need to switch reg because reg is definitely the biggest of the 3, and we don't care about the biggest, we care about the middle. And so once we get here, we now want to check reg is greater than int. Jump if true, 3 compare. excuse me. Out equals int. Wait, out equals reg. Output equals int. Line 5. Oh, let's just get rid of. Oh well, I can't. Ha! Yatta! Look at that. Well, why did I do that? That doesn't actually change anything. But I did it. That is a mess. That is a mess. Oh, right. Check input equals null. Jump if true. End. End. Output equals reg. Boom. Oh, why? Right, I'm dumb. Did you see how I was dumb there? Oh, no, I'm not. I wasn't dumb. Yeah, no, I don't actually care. Int equals input. Switch int. Okay. So I need to stick int in switch. And here is loop. And so in our loop, the first thing we want to do. Well, let's also go ahead and int equals 1. Reg equals 1. And what we're just going to do here is we're going to do reg is going to be our big number. So we're then going to switch int check reg is greater than int jump if false end well, I can switch int output equals Wait, no. Just end. I don't like that. It's like I don't like that. Actually, I don't like. This seems fine. Let's just int equals 0. Y'all having fun out there? So, beef stew's always fun. Okay, fine. Fine, I won't. I can't. I won't cheat. I feel like I'm needing 4. But I can't. I can't do 4. Well, let's try it. Let's figure out my Fibonacci sequence. So, int equals 0. Reg equals 1. Loop. Int reg equals int plus reg. But How with two variables do I get the previous value of reg into int? I don't know. I don't know. My brain says I need 3 variables just for this. Because, like, here, the 0 plus 1 will equal 1, which would be right. But for the next one, like, if I do int equals reg, that's wrong. Ow. Because there's not a 4. Like, I don't... So somehow, I need to calculate the Fibonacci sequence. How much of a mess am I gonna end up having to make with this? So, one thing I know. Int equals input switch int. That for sure is right. And then recursion needs more registers than I have. Yeah, recursion requires more registers than I have. How do I do this with 2 registers? Because I can't. I can't use the switch. I cannot. Can I? Can I use the switch? How do I write this if I use the switch? Int equals 0, reg equals 1, loop. Switch int equals reg switch int reg equals int plus reg switch int output equals reg jump to loop. No, so that's... Okay. So now I have my algorithm. So that is a Fibonacci sequence algorithm right there. But now I need to compare it against my input, which I can only read once. So it has to be stored in a register somewhere. Somehow. I can't cheat and use car as an int because it can only go up to 26. Any thoughts, guys? Oh, look, I overflowed. I overflowed spectacularly. But, So... the heck am I supposed to do this? How do I cut this down to take up to use only 2 registers? Brute force sounds horrible. I refuse. I refuse to do brute force. That's not what they want. There is no such thing as math.rand. I am asking for I am honestly asking for help here, but obviously I'm not going to get any from this chat. I feel like I'm missing something obvious. Switch puts the value into here. This is a not like this is a register. This is a single register that you cannot read to or write from, except for using the switch call. A better name would be swap, but they decided not to call it swap for whatever reason. That's what they call it in TIS 100. That's the swap register, the swap, yeah. I only have one swap register. I have 3 variables. Recursion is not possible. Because recursion would need more than 3 variables. Essentially, the way recursion works is it uses X variables per time you recurse. And so, recursion would not help in this case, even if I could write recursion. I cannot read from output, no. Output is write only. Yeah. Yeah. Like, I thought about... Oh, whooped. I messed up. Okay, fine. What? What's your solution? I will say this is just puzzle 20. So there's perfectly reasonably a simple answer. You cannot read from Switch. Wait, what? Wait, what? I know this is cheating, but not that one. What? What? Uh-huh. Is 0.0162 the golden ratio? Yes, it is. 0.0162 is the golden ratio. You could, but char is limited to 0 to, is limited between 0 and 20, or 1 and 26. There is. The ratio of two Fibonacci of two consistent. Okay. I would not know that. So let's just take that and use it, because I don't think there's another solution. I don't. Apparently there's a solution at 12 lines that people get. Well, I cheated. I cheated this one. We all know it. I cheated this one. But I don't see a way that I was ever gonna do that otherwise. So we have E. So you know what? I'm feeling annoyed enough. I'm feeling annoyed enough. Let's. How much do I have to do here to clean this up? I need to save 1 line and 7 cycles. Oh, look, I saved 1 line. Yeah, I'm good. Oh my goodness. Oh my goodness. Wait, what? Can I just do this? Yes, I can. Yes, I can. Okay, so... what's that doing over there? So what do I need to do here? I need to save 100 cycles and one thing. I overestimated how correct I had to be in these when I was originally writing them. I made the assumption that I needed to get to the end of the function. But no, I don't. I just needed to output all the right information. So, yeah. Oh. 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 Can you see why this is really, really, really hard, Quellis? Can you see why this is really hard, Quellis? Ah! somehow, I need to multiply 6.7 times 5.7 for this first one. But I only have two things. I only have one thing that I can read from that can store floats. One. This is madness. Hooray! Aha. Look at that. Look at that. Okay. Well, it's getting late enough that I probably should... Oh, well, this is really easy. Okay, fine. like this better be. Oh, look. That's exciting. Oh, no. I'm slightly unoptimized. That's too much work. That's too much work. Let's try to optimize this. I made it worse. How did that make it worse? Oh. Somehow that made it worse than my best. Oh, what am I doing? What? That's one of the problems. There we go. What? 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 Okay, so that's better. I clicked a button, not the button I meant to do. Okay, well, I don't see what I'm doing wrong here, and I'm getting tired enough that it's just time for me to be done. So, thank you for coming out and watching. We got a demo done today, demo song done today. And we got, like, halfway through the story of this game, it looks like. So, yeah. Night. See ya.